And calculator, just like your last quiz. You'll do the no calculator part first, followed by calculator. I think the no calculator is just like a front side, and then the calculator is front back. Okay, so just as a quick review, on Friday, we did the law of sines. It's not in your textbook. We want you to have some experience with it before you go to Algebra 3 or Honors Pre-Calculus. And we talked about law of sines. We're not using the congruence postulates, angle, side, angle, 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 side. We're just saying these are the bits of information that were provided. So you can do law of sines with angle, side, angle, or angle, angle, side, and also with that bad word one, side, side, angle. You don't have to worry about it in Big case. We just talked about it on Friday. Okay, today we're going to look at law of cosines, and the law of cosines is side, 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 and side, angle, side. So the difference between side, angle, side, and side, side, angle is where the angle is. In order for it to be side, angle, side, you know two sides, and then you know the included angle, so the angle in between them. Okay, I'm going to give you a triangle. And it doesn't matter what your triangle actually looks like in terms of shape. Just remember how you label it matters. So make sure that your side A is opposite angle B, or your side A is opposite angle A, your side B is opposite angle B, your side C is opposite angle C. And remember, just to kind of quickly review from Friday, these are triangles that are not necessarily right. So I don't know that any of those angles are 90 degrees. Okay, so here's the law of cosines. One form of the law of cosines looks like this. A squared equals B squared plus C squared, that sounds familiar, doesn't it? Minus 2BC times the cosine of angle A. And then there's that other stuff. We're not going to do the proof of the law of cosines, but obviously there's something at play with Pythagorean theorem, right? And like, we didn't do the proof of law of sines, we're not doing the proof of law of cosines, but you should probably see those next year. Okay, now this form for law of cosines is when you want to find a side. Because look what's on the left side, just little a squared. So if you want to find side A, you'll do all this work, b squared plus c squared minus 2bc times the cosine of A. And then you'll still have to do what at the end? Square root, right? You'll have a squared equals all this stuff, and then you'll square root both sides. So now look at what you need over here on this other side. You need side B, you need side C, and you also need angle A. So look at that in the picture. I need side B, I need side C, and I need angle A. This is used when we have side, angle, side. Now, this works for any side. So there's two other versions of this same rule. What if you want to solve for B? Yes. So the included angle is always going to be the angle opposite the side you're trying to find. Inside angle side. So where we had all the B's, we replaced them with A's. Now, on the test, I will give you the law of cosines. Okay, so you'll practice using it and applying it. You won't have to memorize it. Okay. And could you imagine there's a third one? Okay, if you want to write it down, you can. It's going to be c squared equals a squared plus b squared minus 2ab times the cosine of c. When I tell my pre-calculus students, like when we do law of cosines, I just tell them, memorize one of them, and then you can apply it to any. It's like the side that you're trying to find, you have to know the other two sides and the angle in between them. So like just plug them in. Now, the other version of law of cosines is not side angle side, but side, side, side. So what if I knew all three sides of a non-right triangle? How would I be able to find the three angles? Okay. So to find an angle, this is going to be our side, side, side version. Okay, we're basically taking this equation and we're sort of like solving backwards. So if you wanted to find an angle, you'd really want to get to like angle A, angle B, or angle C over here. Okay. So I'm going to start with A. Suppose we want to find angle A. Well, to get this cosine of A all by itself, it is being multiplied by negative 2bc. But before I can get rid of the negative 2bc, I have to move any addition or subtraction to the other side first. So I'd actually subtract b squared and subtract c squared. So if you could imagine, that'd be a squared minus b squared minus c squared. And then it would equal negative 2bc times the cosine of A. But of course I would have to divide by negative 2bc. And when I divide my a squared minus b squared minus c squared by a negative 2bc, to get rid of that dividing by a negative, I'm just going to change all the signs of the a squared minus b squared minus c squared. So it's actually going to look like this. B squared plus c squared minus a squared all over 2bc. So then I don't have to worry about that negative. This is the angle version. And when I, like talk to my pre-calculus students to try to help them, because they have to know the law of cosines, what I always tell them is like, if you're looking for angle A, you're subtracting the a squared. Okay, that's that side that's opposite that angle is the one that you subtract. The others are the ones you add and the ones you multiply by 2 in the bottom. So you could imagine there's two more versions, right? Cosine B. Well, if I'm finding B, B is going to be the one I subtract. So it would be a squared plus c squared minus b squared over 2ac. And the cosine of angle C is a squared plus b squared. I like to put everything in alphabetical order. A squared plus b squared minus c squared all over 2ab. Okay, now this is super helpful. You should always find the largest angle first. This goes to something that you don't yet know about with inverse trig functions. We've been doing them in our calculators to solve for angles in pictures that really look like geometric triangles, just triangles in space. So of course the angle is always going to be positive. But when you inverse sine and tangent, the calculator will either give you an angle from negative 90 to positive 90, but when you inverse cosine, it'll give you an angle from 0 to 180. So if you do the largest angle first, you'll get an angle from 0 to 180, so if your largest angle is obtuse, you'll find it right away. Then, if you switch over to law of sines, you won't have any issues with the ambiguous case. If you don't find the largest angle right away, it's possible that that's an ambiguous case and you haven't found the largest angle you needed to find its supplement. So to avoid that whole issue, just always remember, if you're finding angles in side, 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 find the largest angle first. How will you know which angle is going to be the largest angle in the triangle? It is opposite the largest side. So whichever side is labeled the biggest, like if side A is the biggest, then you can find angle A first. And at that point, then you can switch over to law of sines, or you can continue to use law of cosines. I like to use law of cosines over and over again, but you can switch over if you want. Okay, let's do some examples, and then you'll have some time to work on your homework. We'll do our first example, side angle side. Remember, your goal is find all the angles, find all the sides. So what I see in this picture, I know two sides and the included angle, so that's side angle side. When I do side angle side, I can use the law of cosines right away to find this third side. So I'm looking for side B. So I'm going to use B squared equals A squared plus C squared minus 2AC times the cosine of angle B. And just plug in. B squared equals 22 squared plus 19 squared minus 2 times 22 times 19 times the cosine of 81. I would just type all of that in at once. I wouldn't break it up. Sometimes people do this weird thing where they do 22 squared plus 19 squared minus 2 times 22 times 19, because those are all nice numbers. Then they hit enter in their calculator, and then they multiply by cosine 81. But then you've just violated PEMDAS. You added and subtracted before you ever multiplied by cosine 81. So I think it's just best to just do it all at once, left to right. And make sure your calculator has that little degree mode, or you know you're in degree mode.
I got a negative number.
Jet has 714. Does that seem right?
Yes.
Oh, what?
Just go up and hit enter again. 714.22. Help your pod mates out if they're not getting 714.22. I'll be walking around. Are we doing okay right here? Is it okay back here? Okay, so that's equal to b squared. We still have to square root. And what did you guys get again? 26.72. Okay. So now we know side B is 26.72. I'm going to practice law of cosines because that's what we're learning today. And it seems like you guys did really well in law of sines over the weekend. So I'm going to find my missing angles. I'm going to use the law of cosines because that's what we need the most practice with, right? Let's see. Well, 26.72, that's my longest side. So I already know my largest angle. So it really shouldn't matter because now no angle can be more than 81. So it doesn't matter which one I do. Do you guys want to find angle A or angle C first? Angle A. Okay. So the cosine of A is equal to, and what I remember about the cosine of A is I'm going to use the two sides that are including A, and I'm going to subtract the side that's opposite A, that 22 squared. So, I'll write down my formula. It is what? B squared plus C squared minus A squared. That's the subtraction I was talking about, divided by 2BC. So cosine A equals 26.72 squared, which we know is that 714.22, plus 19 squared minus 22 squared, all over 2 times 26.72 times 19. Okay, now I know y'all want to type into your calculator, so I do have one little PSA, public service announcement, okay? If you want to type it all in your calculator all at one time and just get like a decimal to do the inverse cosine of, you can, but you have to be really careful in your calculator. For fractions, if you have addition, subtraction in the numerator, or you have addition, subtraction, or multiplication in the denominator, then you need a large group of parentheses. So if you want to type this all into your calculator all at one time, you'll have to do parentheses, b squared plus c squared minus a squared, close my parentheses for the numerator, divide by parentheses 2 times 26.72 times 19, close my parentheses. If you fail to tell your calculator what you actually want to perform, numerator, denominator, then divide, it won't be able to get the right answer. So let's all type that in, whether you're doing it piece by piece, top, then bottom, then divide, or you want to try typing it all in at once. Let's see if we can get the same decimal value.
And then I got
Okay, I get 0.5820. So if you're not getting that, let me know, or ask your pod members to look at your calculator and see why things aren't going the way you think.
I got a decimal. Yeah.
0.5820? Yeah, for right now, that's fine.
Thanks, Jess.
Did you get the 0.5820 back here? Oh, can I look at your calculator real fast?
I'm scared. I'm just like,
That was pretty big. Really?
Yeah, we didn't. Nothing happened.
But tomorrow, tonight, hold on.
Oh, so you need it in the denominator, you need a open parentheses for
I
the
know,
two.
I don't understand.
Like saying right now, it's divided by 2 and it's multiplying by
Are you
2.
okay on the calculator here?
My trouble with the calculators. Okay, now, it's always going to be a little bit weird because we get that 0.582. Is that the measure of angle A? No, that's the cosine of angle A, right? So how will we actually get angle A? The inverse cosine. So the last step here, like where we had a square root, that one, now we need to do the inverse cosine in our calculator. Have you guys ever used the answer button on your calculator before? Yeah, now's a great time to use your answer. I gotta look at one of the little calculators and be able to tell you which deal. If you haven't ever used the answer button and you've got that 0.582 up there, then you can just hit second cosine to get the inverse cosine, and then do second negative, and then it'll look like ANS. And what it's doing when it does ANS is it will take the previous answer. So if you have a 0.582, blah, 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 it'll take that answer and stick it in for you, substitution. So then you don't have to type it in. This is the wrong answer. Let me do mine real fast. Are you in degrees?
Yes.
Hang on. I got 54.41.
What do we actually do?
We're trying to find angle A.
What are we typing into our calculator?
Okay. If you want, this should get you close to 54.41. Like, it could be exactly the same. Okay. It's good for you to know about the answer function in your calculator because it can reduce the amount of typing that you're doing sometimes. So another way for you to do this is type. You have to have this work above. Like, you have to have 0.582 whatever it was as your last answer. So you have to have done that. If that's your answer, then do second cosine. Second cosine. And so it'll bring up the cosine with the -1. And then you'll do second ANS, or second negative, which will bring up the ANS on your little calculator. And that should also give you 54.41. So this is really a handy tool on your calculator if you're aware of it. It just uses the last answer as a substitution. Is anybody having trouble with their angle A? Let me know. I'll come over and take a peek at your calculators. Okay, so now we have side B, angle A, and we still have to find angle C, but that would be real easy at this point. Subtract from 180, right? So now we know this is 54.41. If we want to get angle C, we can do 180 minus 81 minus 54.41. Somebody give me that number. 44.59. Had to say it fast to get before everybody else, huh? I get it. Okay, what do you think about that? Well, it's a lot of like setup, but you're doing, the calculator's doing all the work for you. You hardly did any math. True? So, some of us, that might be a good thing. Okay, let's try it again. We'll do a side, side, side. Yeah, that's nice. So if you already have all the sides, what are you going to be looking for? Angles. We can't use law of sines at all because we don't have a matching pair, right? And that was true on the other one. There's no opposite side and opposite angle that match. So we have to use the law of cosines. Which angle should we find first?
B.
We should find the biggest angle, which is angle B. So we're going to do cosine of B equals, and use the two sides that are next to B first, a squared plus 10 squared minus 12 squared, and divide by 2 times 8 times 10. Doesn't really matter what order they come in, I guess. 2 times 8 times 10. Okay. Remember, this is good practice for us right now. If you want to do it all at once in your calculator, you have to put in those extra parentheses. You are smarter than your calculator. Calculator does it now. Until you tell it. I got 0.125. I got 82.82. or 82.8? Well, your calculator, remember, didn't I teach you where your button is?
Yeah.
The squiggle button. It's the same thing. Okay, so at this point, since you found the biggest angle, 82.8, you have your pick. Do you want to do another law of cosines? Do you want to switch over to law of sines? It'd really be up to you. You know, just because I'm going to do a law of sines. Why not? So I can say the sine of 82.8 over 12, because that's the matching pair, is equal to the sine of, you want to find A or C first? A over 10. Multiply or cross multiply, so that's going to be 12 sine A equals 10 sine 82.8. Divide by 12 on both sides. So now I got to type that in my calculator. I got 0.8268. And I'll have to inverse sign to get my answer. It's got 55.8. If you chose to go the law of cosines route, you should get the same answer.
When
I did 10 times sine of 82.8 divided by 12. Ooh, yeah. I divide by 12.
just a general question. When you're rounding your decimal for like your sign or whatever, how far do you want to go?
Okay, if you're not going to use the answer button, you need to go 4 decimals out. Just because, you know, like when it's, the sine and cosine are those that don't really end very often.
Yeah.
We had that 1.125. But a lot of times you're getting this long decimal, so you don't want to cut it off at the hundredths. I'd go out at least 4. It gives you a more accurate answer. Okay, and then finding C would be very simple, right? C equals 180 minus 82.8 minus 55.8. Okay, so I'm going to let you have the rest of the time to work on your homework, which is on the back side of your law of sines. Probably another 6 questions or so. Yes, 6 questions. You know, you may decide in the end, that law of sines was more work than just doing law of cosines. Because I actually have to like cross multiply and figure out how to solve, whereas law of cosines I just type in my calculator. So you might decide you like one over the other for finding the angles. That's fine.